So yes, as I was saying, we did fields, so we'll continue. Let's see what's next for fields. Or do we have homework to do first?
I'm not sure. I think so. Yeah.
We do.
Yeah.
That we didn't do yet. Okay, so let's start with the homework. Fields. This one. Are you sure we didn't do this? Well, I suppose I'll see now.
I'm sure that it did magnetic field.
No, I know we didn't do magnetic fields, but the homework from the last one.
No, we didn't do it.
Okay, let's have a look. So,
When you see that.
okay.
See?
Yeah, we didn't do it. Okay. Convert electron volts into joules. So, if you have your calculator, how many electron volts is it? My computer stuck.
1.642 multiplied into minus 19.
But how many in the question? 2.5. 2.5 electron volts will equal 2.5 E joules. And are you giving me the answer for this? You have the answer? Thank you, Adnan. Do you know how to do this?
2.5 multiplied
1.602 multiplied into minus 19.
4.005 multiplied by minus 19.
Okay, and number 2 is 1.5 nanojoules will equal 1.5 times 10 to the minus 9 joules, which equals 1.5 times 10 to the minus 9 over E electron volts, which is, how many now?
1.606.
Yeah, should be a big number. Yeah, so
936
okay, 936.
329 5880.
All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9.36 times 10 to the 9 electron volts, which is 9.36 times 9.36 giga electron volts. Continue. Let's see, what's the story in number 3? What is the potential energy in electron volts of a proton which is equal distance between two parallel plates separated distance 1 millimeter with a potential of 9 volts? So what you have here is this is 1 millimeter. 1 millimeter and 9 volts, and right in the middle here there's a proton, and we want to know what is the potential, and this is the height here. Yeah. So we have potential energy, not MGH, but the other formula QED, I'll call it D, or the other formula, which is the one we should use here, which is QV, which is the charge of a proton multiplied by 9, which is actually, when you convert that into electron volts, conveniently just 9 electron volts. So, how long would it take for a proton to travel from a positive plate to a negative plate if the distance is 1 millimeter and the voltage was 25? So what we have here, one millimeter, 25 volts, positive plate, negative plate, and there's a proton here, and the proton moves down. How long will this take? So I think I'll first find the F. F equals, well, do you know what? I'll do it differently. Because if you think about it, U, V, A, T, S, I know the U is 0, and I'll take down as positive and up as negative. I know U is 0. I know the S is 0.001. So if I knew the V, I'd be finished. I have enough to get the T. And there is an easy way to get the V. The kinetic energy here should equal to potential energy here. So you have QV should equal a half mv squared. So the V will be 2qV voltage, not velocity, 2qV over mass square root. So let's just hit that in on the calculator. Square root 2 times, what constant is for E, the charge, is it 23?
I don't have
That's okay. I think you're 23. Times 25 over mass of the proton. It is a proton, isn't it? I think that's constant number 1. Yeah. So the velocity comes out at 69206. And we want the T. So we'll go with S equals UT plus a half AT squared. The U is 0. So, no, we can't use that formula. Why not?
Which one?
The one I just wrote.
Doesn't give you the T.
No, it does give me the T.
You, huh?
Yeah, then it's good.
Yeah.
You,
We don't have the A. So I'll have to use a different one.
V squared.
No, I'll have to use, no, because that doesn't have the T in it, which is what I want. I'll have to use S equals U plus V over 2T. This one. U is 0, so I can say T equals 2S over V, which would be 0.002 over 69206. Very small. 6 is micro, 9 is nano. 28.9 nanoseconds. Okay? Can I?
No.
No? No?
No.
No, no. I said no and you went, mhm. Now can I go down? Okay. Next one. What number was that? That was number 4. Now number 5. No, that was number 5. Oh, I skipped number 4. That's what I did. Okay, so now number 4. How fast will an electron be travelling if it leaves the negative plate and strikes a positive plate, which is 2 centimeters away, and the distance travelled the potential difference is 12 volts.
So the kinetic energy.
It's the same as what I did in number 5. So will I just skip it?
Yeah.
Yeah. We'll look at number 6.
Yeah.
Yeah. A battery of EMF V is connected to 2 horizontal plates. Oh yeah, this one. So, a battery of EMF V is connected to 2 parallel plates. One plate becomes positive and one becomes negative. An electron is fired at 45 degrees above the negative plate. So this one is positive plate, this one is negative, and there's an electron fired here above the negative plate at 45 degrees and at a speed of 1 kilometer per second.
But can we choose the plates which one's going to choose?
Well, it has to be between the plates because otherwise there's no field. So I suppose you could put the positive one down and the negative one on the top and have the electron fired from the ceiling. It'll get the same answer because we're not considering gravity since the electron's so small. Should say above the negative plate. But I also say the negative plate lies on the ground. The distance between the plates is 10 centimeters. The electron just misses the negative plate above it. Now you see, I think there's a typo here. Because I think I meant to say on the ground is the positive plate. Yeah, it falls back down to the positive. So I have a typo in this question here. I meant to say this is the negative plate and this is the positive plate. Okay. So the electron is fired.
Above the negative?
Yeah, above the positive. No, everything's right in the picture now. So what happens is, well, what would happen? Which plate does the electron want to move to? Yeah. It wants to move up to that one. So it'll move up. And then I said it just about misses the negative and falls back down. Yeah?
Yes.
So what was I looking for here? I was looking for the V. Okay. I think I have this right. If this was a... Yeah, no, this is the way it is. Yeah. Okay, so I want to know what is the V. So let's have a look at the electron here. There's one force acting on the electron. What's the force acting on the electron? The field, which is how much? What's the formula for the force? Do you remember it? QE. And what's the formula for E? Yeah, so QV over D. Yeah. And what is the V in this case? We don't know. What's the Q? We do know, because it's an electron, so it's 1 electron. What's the d? Do we know the distance between the plates? 10 centimeters. So that's 0.1. And the V we don't know. We don't know the voltage. So this is equal to 10 E, whatever that is. I'll just leave it like this until I have my calculator. Times V. Okay? Now, if you look at this and it's moving, and there's a force acting down, what type of problem does this remind you of? Projectiles, yeah. So we should resolve this into a horizontal and vertical. So 1 kilometer per second is 1,000. This is 1,000 cos 45, and this one here is 1,000 sine 45. We should look at the vertical. We want it to just about miss the top. So it's a UVATS. The U we know, it's 1,000 over root 2. The V, we kind of know. What do we want it to be? 0. The S, we would want it to be 10. Yeah?
But why is it root 2?
Huh?
Root 2?
Cos 45 and sine 45, yeah. Yeah.
What are you, I mean, like, why you find the QE, the force, then you give it.
Don't worry, I'm coming back to it. Don't worry. Do we have enough info here to find the A?
Yes.
We do, don't we? So, what formula would give me the A here easily? Let me go to the side for it. What would give me the A? V squared equals U squared plus 2 A S. This is the one I'm using. Yeah. So the A would be minus 1,000 over root 2 squared over 2 times 0.10 when you rearrange this. I'll just hit this in on the calculator and see what we get. Fraction squared minus 1,000 over square root 2 divided by 0.20. No?
The minus.
Oh, thank you. Well, that's okay. I'll just put it here and put the answer there. Thank you. So the A is minus 0.00000. 1, 2, 3, 4, 5 meters per second. Okay, now can I go back to the main question? So now that we know the A, I'll just write it here in red, minus 2500000. Back to the question. So as Mr. was saying, why on earth did I do this if I didn't need to? Well, I'm looking for the V, and I still don't know the V, but I do know the A. And I know F equals MA, and I know the F, and I kind of know the F, but I do know the A and the M. So I can say 10 EV equals mass of the electron times the A, which I do know, it's right here. So my V, you see, you weren't listening because you're falling asleep.
No,
okay, rewind. F equals MA.
yeah.
I know the F. This is it here. I worked it out earlier. I know the M, and I know the A. So I can get the V, because I can say 10 EV equals mass of the electron times 2500000. I don't care about the minus. Really, I should put a minus here because it's going down. So you have a minus and a minus, so no problem. Voltage will equal 2500000 mass of the electron over 10 times the charge of an electron. Well, I suppose I can cancel one of those O's. So if I just take out the calculator and type in 25000 times mass of the electron, which is I think number 3. Yes. Divided by charge of an electron. Okay, I'll get my voltage. A very, very small voltage, 1.42 microvolts. That's the answer then. Not too bad or bad?
Exam question.
Yes. That's the reason I wrote this one, is because I remember seeing it before.
Long time.
Yes, long time ago. The last, not the new person, but the last person who wrote the exam. Got that? Adnan? Yeah?